let us discuss about the fourth colligative property, which is osmotic pressure. I'm sure in your biology you have come across osmosis. Even if you have not come across, I will be explaining, so don't worry. Osmosis means the flow of ions, molecules or liquid from a region of lower concentration to a region of higher concentration. Lower concentration to a region of higher concentration through a semi-permeable membrane. Now, what is semi-permeable membrane? Semi-permeable membrane may be either a biological or a synthetic polymer which allow the movement or flow of ions, molecules or any liquid through it by diffusion. Diffusion is nothing but diffusion is a process which allows the movement of ions, molecules or any liquid through the membrane. Now, osmotic pressure. Suppose we have a liquid in a container. We have a solution in a container which is separated from its solvent by a semi-permeable membrane. Left hand side we have the solution, right hand side we have the solvent, and they are divided by a semi-permeable membrane. Now, it is obvious that the solvent will travel to the solution, but the minimum pressure which can be applied here in order to prevent the solvent to travel to the solution side is known as osmotic pressure. That means the minimum, the least pressure which we can apply towards the solvent side in order to prohibit or in order to stop the movement of the solvent towards the solution is known as the osmotic pressure. But suppose if we apply a very high pressure here, if we start applying very high pressure here, there will be a condition when this solution will start moving towards the solvent side. The movement of the solution towards the solvent side is known as reverse osmosis. I hope this is quite clear now. Osmotic pressure and osmosis. Osmotic pressure is denoted by pi, which is proportional to the concentration of the solution and temperature. We have a proportional term here, we need a proportionality constant. So in this case will be pi is equal to R Ct. R is the gas constant. Now we know that concentration is equal to the numbers of moles of the solute per unit volume of the solution. So now in place of concentration we can write the simplified form, which is pi is equal to R NB T by V. So far we have discussed that NB is equal to the mass of the solute divided by the molecular mass. So in place of NB we can write that R into WB into T by MB into volume. Now we got the molecular mass term. So with the help of this molecular mass, we will now bring all the terms to the right hand side, bringing molecular mass to the left hand side. So MB is equal to R into WB into T divided by pi into V. So with the help of this equation, we can calculate the molecular mass. So with the help of the fourth colligative property also we can calculate molecular mass. So till now we have seen that all the four colligative properties are used for calculating the molecular mass. So you can use any of the colligative property for calculating the molecular mass. But when we use any of the colligative property for calculating the molecular mass, we either get the molecular mass which is higher or lower than the actual molecular mass. Getting a higher or a lower molecular mass as compared to the actual molecular mass indicates that the molecular mass is abnormal. That means the molecular mass which we are calculating with the help of colligative property is coming out to be abnormal. So here we can say that when we calculate molecular mass by using any of the colligative property, we get abnormal molecular mass. So this abnormal molecular mass needs to be corrected. Vant Hoff, he introduced a factor which is Vant Hoff factor I in order to correct the abnormal molecular masses. Now let us see the Vant Hoff factor, which is denoted by a small I. Now, this abnormal molecular masses which is occurring, it is occurring due to two reasons. One is association and the other is dissociation. Due to association and dissociation, abnormal molecular masses occurs. Now let us first try to be clear about what association and dissociation is. Suppose we take NaCl and dissolve it in water. NaCl will dissociate into Na plus and Cl minus. Here Na, we are taking 1 mole, but after dissociation it is converting into 2 moles. That means initially we are taking only 1 mole, but as we dissociate we are getting 2 moles. That means NaCl molecule is dissociating into Na plus and Cl minus. So this process, when 1 mole breaks up into 2 moles or more, it is known as dissociation. And when dissociation happens, the molecular mass decreases. Because as a whole, NaCl will have a huge molecular mass, a larger molecular mass. But when this NaCl dissociates into Na and Cl, the molecular mass will tend to decrease. So this is known as dissociation. Now when acetic acid combines with a solvent, they do not dissociate. But what happens is acetic acid go and associates with the solvent in order to form a bigger molecule, which is also known as dimer. Acetic acid combines with solvent to form a bigger molecule. That means what is happening here? Association is happening. Acetic acid is associating with the solvent to give a bigger molecule. Since we are getting a bigger molecule, it will obviously have a larger molecular mass. So as a result of association, the molecular mass increases. So these are the two reasons why we are getting a larger molecular mass and we are getting a smaller molecular mass as compared to the calculated molecular mass. Now what Vant Hoff did was, he introduced a factor in order to correct this abnormality of the molecular masses. Vant Hoff factor can be defined as the ratio of normal molecular mass by abnormal molecular mass. it can also be written as calculated colligative property by observed colligative property. This is how Vant Hoff factor is defined. Now, in order to calculate the abnormal molecular masses, Vant Hoff factor needs to be multiplied towards the right hand side of the colligative properties. Now, for the first colligative property, which is relative lowering in vapor pressure, which is given by PS naught minus PS divided by PS naught equal to the mole fraction of the solute. As I said that the Vant Hoff factor will be multiplied towards the right hand side. So in order to calculate the abnormal molecular mass obtained from the first colligative property, that is relative lowering in vapor pressure, we need to multiply Vant Hoff factor to the right hand side. In this way, the abnormal molecular mass obtained from the first colligative property can be corrected. Now, in order to correct the abnormal molecular mass obtained from the second colligative property, which is alleviation in boiling point, del Tb is given as molar alleviation constant multiplied with molality. In order to calculate the abnormal molecular mass obtained from the second colligative property, we need to multiply Vant Hoff factor towards the right hand side. By multiplying the Vant Hoff factor towards the right hand side of the second colligative property, we can correct the abnormal molecular mass obtained from this second colligative property. Now the third colligative property, which is depression in freezing point, can also be corrected by multiplying Vant Hoff factor towards the right hand side. So Vant Hoff factor, if we multiply towards the right hand side, abnormal molecular mass obtained from the third colligative property can be corrected. Even the fourth colligative property, if we multiply the Vant Hoff factor towards the right hand side, the abnormal molecular masses obtained from the fourth colligative property can be corrected. So simply you can see in all these, just by applying the Vant Hoff factor towards the right hand side, all the abnormal molecular mass tends to get corrected. This was the sole reason for Vant Hoff to introduce Vant Hoff factor, which is denoted by a small I. So this was all about colligative property and how the abnormal masses obtained from colligative property can be corrected. In our next session, we will start up with a new chapter. If you have any doubt, you can also put it in the chat box, or you can even approach me personally. Till then, take care.